gentlemen, my name is John Belkowitz, and I am the host of your amazing YouTube video that we're putting together tonight, which is all about making concrete stronger and last longer. We've been talking about making concrete more ductile, a tougher material that can handle not only tensile loads, but fatigue cycles when it comes to tensile loads. And we looked at steel failure, and we analyzed not only as the steel goes through that necking, as well as the you know, what you guys don't see behind the camera is that Patchouli is constantly like giving me the finger or pointing at the camera in an angry way, because I have a tendency of looking down when I talk. So if you see me chuckle every once in a while, it's probably because Patchouli is yelling at me in a very quiet way. She does enjoy yelling, not only at me, but at Whitney too. So what we wanted to do is get an internalization, a basic understanding of the science of how these materials blunt the localized stress, slow down that crack propagation, and stop that catastrophic failure known as cleavage. So we went through not only the brittle failure, but then this blunting or ductile behavior of a crack failure, and how do we extend that to the ceramic-like behavior of concrete? And there are many materials that can do it, but the singular school of thought that I want to present is that if we can take the concept of these impurities, those softer but tougher materials, but combine that into the concrete composite, specifically in the hydrated cement matrix or even in the granular skeleton, where that when a crack is initiated and the crack propagates, when it hits this plastic zone, it starts running into these impurities that have been added to the composite, and the catastrophic forces that would cause failure of the atomic bonds and then the planes, which leads to cleavage.
You just like to say cleavage.
That crack energy would be blunted, and instead of getting that atomic bond and plane failure, you would get a wider plastic zone where the energy is actually distributed along that plastic plane, and then the crack would stop. So different ways of doing it, adding those impurities, acrylics, polymers, plastics, fibers, steel fibers, synthetic fibers, carbon nanotubes, anything that has a greater toughness or a capacity to absorb those catastrophic forces that would ultimately cause the failure of the brittle matrix of the concrete composite. So again, it's taking those tougher or even softer materials and mixing it into the concrete while it's in its fresh state, so that when it hardens, it becomes part of the composite and it creates this type of blunting environment that leads to ductile behavior. So I believe we're actually going to be putting a mixed design together under our formula day. I don't know when we're going to do that, but we also, the biggest problem is, have to do samples alongside of that to show, you know, this phenomena in action. So we'll have to look at the test. I don't think we're going to do a flex test because we don't want to do the beams. The beams are huge. So I think we might do splitting tensile or some modified version of the flexural beam test. So we'll let you know. We'll get back to us. I hope you enjoyed. I hope you learned. Let us know if you got any questions. Throw in the comments section below. Don't forget to like, subscribe, check out the Concrete Note. You rock, we roll, go concrete, beat asphalt.